Welcome back to this new video. In this video, we are going to talk about divisors of a number. What is basically divisors of a number? So let's take the input of 15. So from 1 to 15, what are the numbers that can divide 15? Those are the divisors of a number. This includes prime numbers as well as composite numbers. So in this case, if we take 15, we know 1 will divide 15, 3, 5 and 15. 2 will not divide 15, right? Because it doesn't divide it properly. So these are the divisors. If you take 20 as an example, 1 can divide 2, 4, 5, 10 and 20. Got it? And for 13, 1 and 13. I think this should be really straightforward. Okay, so first let's solve it in a naive way. So what is this naive way? What you need to do is just run a loop from 1 to n and check whether a number is divisible. Okay, if number is divisible, that's all. Basically, you just need to run a loop and then check if the number is divisible. If the number is divisible, you just add it to the array. Got it? Hope this is really simple. So see you in the solution video. Thank you. Welcome back to this solution video. So let's see how to solve this naively. So let me create a new file 09 divisors.js. And inside this file, let's create a new function called divisors. And let's say it takes the num as an argument. And inside this, as a first step, let's initialize the output array so that we can push the divisors. Now we'll just run a loop from let I is equal to 1, and this goes until less than or equal to num, and then we will just increment by 1. And inside this loop, we will just check whether if num modulus I, that whether it is divisible by I. Basically, we're checking whether num is divisible by I. So if the remainder is 0, then we know it is divisible. So we'll just push output.push of I. And in the end, we will just return the output. Hope this is really straightforward, right? We just run the loop from 1 to num, and then whenever a number is divisible, we just push it to the output array, and then at last we return it. So let's add some test cases. So console.log divisors of 15, and let's add a couple of more. So 20, 13, and then 100. Cool. So now let's try to run this. So node 09 divisors. Yeah, as expected, you see we're getting the output as 1, 3, 5, 15, 1, 2, 4, 5, 10, 20, 1, 3, 1, 2, 4, 5, 10, 20, 25, 50, and 100. So these are the divisors in a naive way. So what is the time complexity of this? As you could see, it runs theta of n times. And what is the space complexity? Space complexity, it is the space of theta, or a big O of divisors, right? Number of divisors. But ideally, this is just for the purpose of us, right? To just return an output. So you can, if you're considering this, then you can consider it as big O of divisors, number of divisors. If not, you can also consider it as big O of 1 as well, if you're just printing, right? So basically, the space is debatable. But as for the time complexity, it is big O of n. Okay, great, cool. So see you in the next one. Okay, welcome back. In this video, I'll give you an overview of how to solve this more efficiently so that you can try to solve it on your own, and then we will meet back again in the solution video. So basically, this is based on the fact which we have already discussed. The fact is that divisors always appears in pairs. So for example, what are the divisors for 30? 1, 30, 2, 15, 3, 10, and 5, 6. So basically, if you think, when we are trying to get one of the divisors, we also get the other divisors as well. Okay. And only thing is, you need to just run this loop until square root of n, right? Because until then, we will know above that, we will not find any divisors. So basically, you just need to run a loop from 1 to the square root of n, and then you will get both the divisors. But only thing is there are some cases, for example, in the case of 25, you see 5 and 5. We're getting 2 5s, but we just need to print once, right? So you need to be wary of that. Just think about it, how you can print it only once. Also, to complicate this problem, I'm going to say you need to print these devices in order. I have given clues, like devices always appears in pairs, and you need to run from 1 to square root of n. And when you're running for each of the devices, you also get another divisor as well. But the challenge is you need to print the loop in order. Okay, so think about it, try to solve in the coding exercise. If not, just look in the solution video. Thank you. Welcome back, guys. So I hope you are able to solve the problem. I know it was a little tricky, but no worries. Let's solve it together now. Yeah. So I'm going to show two ways. Two ways meaning like first way will not give you the sorted output, but the third one will give you the sorted output. But yeah, anyway, let's start. So function divisors 2 of num. Okay. As usual, let's assign let output is equal to an empty array. And then what we are going to do is that this time we are going to run the loop for let I is equal to 1. And then you remember it's going to be square root of n. So I times I is less than or equal to num. And then we will do I plus plus. You might have a question like how this loop is getting worked, right? The thing is, until the square root of number and like I into I is less than or equal to num, we will find the devices. But apart from that, we can't find the devices because the numbers will be greater than the num if you multiply by anything. So that's the reason. For example, let's say we are finding 25, right? So what is the square root of 25? It's 5. So we are going to run this loop till 5. But let's say it's going to be 6, right? In the next point is you can't have a divisor or a value that will divide 6 into something equally so that you will get 25. So that's the reason this is the mathematical form idea of going till the square root of n works here. Okay, so we are also going here till the square root of n. And if you remember from the last video, I said divisors appears in pairs, right? So we are going to make use of the fact over here. So what we will do is like if num plus modulus I, which means if the remainder is 0 after doing the modulus, then we know we have this divisor. So output dot push of I. But at the same time, we know it appears in pairs, right? So what we will do is like if of math dot floor of, remember, if we divide two devices, that is, for example, let me show it to you guys. Yeah, for example, if you take the 15 as the case, right? So what are the devices? 1 comma 15 and 3 comma 5, right? So if you multiply 3 and 5, we get the number. So now we have this one divisor. So in order to get the other divisor, what we can do? We can divide the number by this divisor, right? So that's what we are going to do over here. So math.floor of num divided by I. Why are we doing math.floor? Because we don't want a floating point number, hence. And what we are going to check is if this is not equal to the case of I. Why are we checking this condition? For example, if you take the case of 25, right? When you take the case of 25, yes, if you see 5 into 5 is one of the devices, and we need to print only one 5 and we don't want another 5, right? So that's the reason we are checking whether the math.floor of num slash I is not equal to I. If this is not equal to I, then we will push it. So we will just push the math.floor of num slash I. Okay, and at the end we return the output. Great. And let's see how this test case fans out. Okay, now if I try to run this program, you get the same output. Cool. but if you see, the outputs are not sorted. So let's make it sorted. So in order to make it sorted, I will just copy this again. And let's say it is divisors of 3, and we have let output is empty array. This is fine. And after that, what we will do is like, we will have one loop and we will just remove this. But one small change we are going to do, I will explain why we are making that change shortly. Rather than less than or equal to, we are just going to do less than. Okay. Now what we will do is like, we will run another loop, and this time we are going to do a reverse of the loop. So let me take this variable outside. So let I, okay. So for example, let's say we are doing this for number 20. Okay. So square maximum it will go till is 4, right? Because 16 is the, which is 4 into 4 is 16, is less than number. But if you do 5 into 5, it is greater than 20. So what we will do is like, this I will go till 4, and then in the next loop when I becomes 5, this will not be executed. So now we know when we come out, I value is 5. So what we will do is like, until I is greater than or equal to 1, then I minus minus. Okay. Now inside this loop, what we will do is, we check whether if num percentage I is equal to 0. So whether the remainder is 0, whether it is divisible. If this is the case, then we can just do output dot push of math dot floor of num divided by I. Okay, cool. Now if we try to run this problem, okay, I need to change it. Divisors of 3. And let me zoom in a little bit. I forgot to zoom, sorry guys. Okay, so now I have changed this to divisors of 3. Now if I try to run, it looks like, maybe I can, yeah, one step above, it looks like we are getting the output correctly, right? But unfortunately, if you see for the second output of divisors 3 of 20, we are getting a duplicate, right? And rest of the things seems to work fine. So in order to avoid this duplicate, we need to make slight changes. So what we will do is like, I'm gonna say const temp is equal to, we know at this point I is 5. So I'm gonna do -1 of it. Okay. And inside this check, I will also add another ampersand, and I will say not of math dot floor of num divided by I is less than or equal to temp. Basically what I'm trying to do over here is like, if the number which we are trying to get this right, the other divisor, if it is less than or equal to temp, then we know we have already calculated that and pushed it to the output array over here. So I'm just going to check whether that is not the case. So if it is not less than or equal to temp, then I just do an output dot push. Okay, cool. So now whenever the number is less than the already processed num, we will not push it. Now let's see how the output looks like. So if I try to run again, you see now we don't get the duplicate. Okay, cool. So now that we have solved this efficient problem, what is the time complexity of this? If you see, we are trying to run it square root of times and then some kind of loop, right? So basically it's kind of running square root of n times, and space complexity, depending on whether you take this into account or not. If you take into account, then it's the number of devices, big O of devices, if not big O of 1. Cool. So see you in the next one. Welcome back. This is a follow-up video on the previous lecture. I forgot to inform something or explain something like as to how this works compared to this previous method. Okay. So basically what we are trying to do is, let's take this 20 as an example, right? So once again, okay, when we take this 20 as an example, you see we have 2 loops now, correct? So initially it starts with 1, whether 1 is less than 20, yes, and yeah, it is also divisible, right? We push the 1, and now we come to 2. 2 into 2 is whether it is less than num, 4 is less than num, and whether it is divisible, yes, so we push the 2 as well, and then I becomes 3, and 9 is less than or num, yes, so but in this case it is not divisible, so we don't push it, and then I becomes 4, which means 4 into 4, 16 less than num, and 4 is divisible, yes, so we push the 4 as well. But now you see, compared to the last program, here in the last program we had less than or equal to, rather over here we have just less than. Okay, so you have processed till 4, and then when I plus plus is done, now I becomes 5, but then 5 into 5 is not less than 25, right? It's 25 is not less than 20, so which means we come out of this loop. So at this point what happens is, like, I'm going to take a temporary variable, so until whatever is processed, which means whatever is processed meaning here we have I as 5 minus 1, so until 4 we have processed inside this loop, right? So I'm setting this const temp value as 4. Now we create another loop, and in this loop what we are doing is that we are running this loop until I is greater than or equal to 1. Now what is the value of I? It is 5. And now we check whether num percentage I is equal to 0. Of course 5% I is equal to 0. But the thing is, we also check math.floor of num by I. Num by I is what? 20 divided by 5, which is 4, and it is less than or equal to temp, because it becomes true, right? Because in this case temp is also 4, so we don't push the 5 over here. So what happens? We decrement the I. Now in this case it becomes 4. When it comes to 4, num percentage I is of course is equal to 0, but this time math.floor of num.I is 5, and it is greater than temp, so we just push the 5 over here. So that's how whole thing works, and we also remove the duplicates. Okay, cool. So see you in the next one.